Hi everyone, in today's video we're going to look at adhesives and other joining methods. So what you need to know is basically what is meant by the term adhesive, what are different kinds of ones that you can use, and then how do you basically join similar or dissimilar materials together. So, first thing, adhesives. So there are advantages and disadvantages. So main advantage being that it's invisible, so you actually can't see the joint, so you don't see like nuts and bolts or anything like that sticking out, so it can be quite aesthetically pleasing. It doesn't affect anything. They don't cause any damage to the original shape. You've not got to drill into something, you've not got to weld it or anything like that. It will let you attach dissimilar materials together, so you can do metal to glass, metal to plastic, plastic to wood, that type of thing. Some adhesives add protection, so they might seal it to make things more watertight, so when you have like sealant around window frames or bathtubs, that type of thing. Disadvantages being that generally speaking, on their own, they're not that strong. Normally they're reinforced with something else as well. They do require good surface preparation, so it might be that it needs to be a completely clear surface or it needs to be a bit of abrasive to make it stick. And generally over time they do weaken just from general wear and tear. So with adhesives, there's generally two groups. You've got natural, which are derived from animal or vegetable extracts, and then you've got synthetic, which are include things like epoxy resin. So we're going to go through the most common ones that you'll probably come across. So the first one is PVA, so full technical name being polyvinyl acetate. You can just say PVA in the exam. So most commonly used for doing wood to wood. So it's water based, it's white in colour, but dries clear. So it soaks into the surface, I can't talk, of the material. So the material has to be what's called porous. So the porous being that it's got little holes, like your skin's porous. So basically, there's some very, very fine holes in the material and it'll soak into it. You can reinforce it with wood joints or screws or that sort of thing. Um, Standard PVA typically is not water resistant. So if you just PVA glue some together, put it outside and it rained, over time that will fall apart relatively quickly. Just one with the whole layer being porous, there's a reason why you couldn't use, say, acrylic and MDF and use PVA glue to try and bond those together, because it can't soak into the acrylic, it will just slide around. Next, you've got contact adhesive. So this will pretty much let you put anything to anything else. So you do timber to timber, metal to wood, metal to plastic, plastic to metal, glass. So this will do quite a lot. So in terms of the prep for this, you have your two materials. What you'll do is you'll put a fine layer on both materials. You let it like go tacky, so dry a little bit for about 10-15 minutes. When you go tacky, it's going to go sticky to the touch. Once you've done that, you then clamp them, press them together, and it sticks very, very quickly. So you don't need to clamp it. It's like an instant sticking. Quite a lot. This is used for car dashboards. So you have your contact adhesive on both, let it dry a little bit, touch them together. So that's why you don't see any welding or bolts or screws or things on like your dashboard in your car. Next, you've got UV hardening adhesives. If you have had any dental work, you'll have that. I believe that certain nails, like acrylic nails and that sort of thing, have done that as well. So what you have is you have a clear liquid that essentially it cures when exposed to UV light. So when we talk about dentist stuff, that's when they put like that ray gun looking thing and it shines that blue light onto you. So it contains a photo initiator, which basically means it absorbs the light and it starts to set it as a solid. So it will be used to join things like metal, glass, and polymers together. So it sets very, very quickly. It doesn't require any hardening time, and you don't need to mix it together or anything. It doesn't have like the glue and a hardener or anything like that. You don't have to mix it together. So it dries completely clear. So it's used quite a lot in glass related things, but also that's why it's used in dentistry. If you've had any like caps, and so my two front teeth, I got two caps on there. So essentially, once it's done, they use the UV hardening so you can't see where the real tooth ends and where the fake tooth begins. Next, you've got solvent cement. So there's a few different kinds of solvent cement. The most common one you'll probably see in colleges and schools is 10-sol-12. Its typical name is called dichloromethane. It's a very, very, very strong solvent. It will only stick plastic to plastic because what will happen is essentially it softens and melts the surfaces of the plastic, so it essentially like welds it together. That's why that will only work on just plastics. It will work on loads of different kinds of plastics, but it will only do plastic to plastic. So now we're going to have a look at joining metals. So you got MIG welding. So this is the one we've got in college. So you have got basically you've got your welding torch, and inside that torch you've got a wire that is fed from the actual unit itself through the actual welding torch, and then that has a spark with the metal, and that will make a very thin gauge like weld along there. So it's nice to be. It can be very accurate. You can do things like bike frames and that type of thing. What you can't do is aluminium because you can't get so high enough temperature properly. Um, of all the different kinds of welding, MIG is probably the easiest one to try and learn. Your next one is TIG. Now it works pretty much the same way, but the only key difference here really is that with MIG, the wire, if you can see my mouse now, is fed through the actual tube, so you can just do that with one hand. With TIG, you have to have the rod in a separate hand, so it's a lot more difficult to do because it requires a lot more skills, a lot more steadier hand. So TIG welders are very skilled individuals. It's used a lot of like stainless steel, non-ferrous metals, and aluminium. Next, you've got oxyacetylene welding. It's not really used as much anymore. So essentially, you've got your oxygen, and then you've got your acetylene in two different canisters. And then what you do is once you need to weld them, you will release both gases and they'll mix together within the torch, then along with the spark, and then that will create your flame. And so it's used to do low carbon steels, like sheets, tube, and plate, and that type of thing. It has become obsolete since MIG and TIG has come into play, but in instances where you're sort of out in the middle of nowhere, so if you think like places like Australia and America where they've got like vast nothingness, and say you've broken down, if there's like random garages around or repair places, they may have oxyacetylene welding because you don't need electricity. You can do that like away from everything. So it's still got uses, although you wouldn't really find this in like colleges or workplaces in the UK anymore, because MIG and TIG have come in. But it's still very good. But you do have the risk of if you burst those canisters and they mix together, you're going to get a big explosion. Next, you've got brazing. Brazing is probably one a few people may have done before. It's also known as hard soldering. So essentially, you have your two materials. You have to a lot of the material or metals rather, you have to like clean them and make the surface shiny in order to actually physically join them. So what you'll do is you'll have the material looking nice and shiny. You'll add some flux to it, which stops it oxidizing, so stops it becoming not shiny. You will apply heat to it, and then you have your brazing rod, and then as you're melting the brazing rod is like the glue that joins them both together, and that goes within the cracks and it joins it together. Brazing is weaker than all the other forms of welding. It still has its place. You can make it if you're good at it. It could be like because it's the brazing rod's a different colour, like a coppery sort of colour. Can be quite part of the design. Sometimes you can try and include that into the look of it, but it's also not really that strong. So then you've got soldering, which kind of works in the same sort of way as brazing in a sense. Is soldering you may have done in secondary school, you've done any electronics. So soldering irons normally get to about 375 degrees ish, depending on what you're doing. So the tip gets to that hot. What you'll have, you've got to make that nice and shiny again. So it's transferring heat quite well. You'll have your solder. You'll put a little bit of solder onto the tip, and that'll sort of like make sure that the heat is getting there and there. Then you'll hold your soldering iron onto the component you want to solder, and then slowly apply some solder to it. So you want to make sure, as long as the component you're trying to solder to has got enough heat into it. So essentially, normally the technique is you hold it on the area, count to about 10 seconds, and then add some more solder, and that'll make a little pool of solder on there that you can then finish on. So other metal joining methods, so you've got things like self-tapping screws, machine screws, nuts, bolts. So if we go from the top, so up here you've got self-tapping. So self-tapping screws essentially means it will make the thread for, so if you're doing that into a material, it will make the thread for you, rather than if you need to make a thread, you use what's called a tap and die, hence why it's called a self-tapping. Because normally a tap you actually have to physically make the thread to be able to do something, but self-tapping screws, as soon as you put them in, it will make the thread in the material for you. Riveting, not just an old school word for exciting. So you used to have to do it manually, so you'd have your actual rivet. You'd drill a hole into your two materials with a little divot. You'd put your rivet in there, and you would hit the top of the rivet, and it would flatten it, and then that would join those two metals together. Essentially, I always say riveting is almost like stapling for metal. Nowadays, pot riveting is used, so because you can buy a pot rivet going, and they're quite cheap. Essentially, you put the rivet inside the machine, still drill your hole in two materials, and you just squeeze it together like a stapler, and then that will crush the two bits that are joined together. And then in terms of like your bolts and your screws, you've got your flat head or your slot head, you've got your Phillips head or your cross head. Then you've got your posi drive. Now the posi drive is very similar to Phillips head, except it's got extra bits that essentially stop it from messing up as you're using the torque from the electric screwdriver, so it means it's less likely to mess up the surface and you can't get it back out again. So we're going to look at some timber-based ones now as well. So first of all, you've got knockdown fittings. Now these are ones that you will see in things like flat pack furniture. So we'll start from top left. So you've got basically a batten. So rather than cutting a joint into your two pieces of wood, you have your two pieces of wood and you have just a batten, a length of 2x4 or whatever it may be, and you'll screw it into one surface and screw it into the other surface as well. Next, you've got cam locks. Now, if you've ever assembled like a desk or anything from IKEA, anything flat pack, so there'll be holes drilled in there, and then this cam will fit in there. You'll have your screw, and then you just turn the cam, and that will literally lock it in place. They are very good. They're quite easy to take them apart again as well. You have also got ridge joints. So these are ones where you might have like underneath the drawers. So you have like a little plastic sort of 3D triangle that you'll screw into one piece and screw into the other that will join together. And then you got, similar to the battens, you'll have your blocks, except you've got two blocks. One's already attached to one piece, one's already attached to the other piece, and you'll just join those together as well. So traditional woodworking joints. So there are more joints in the world that exist than the ones I'm going to show you. If you've got any follow any woodworking or making social media page or anything like that, you might see all like these amazing Japanese woodworking joints that are fantastic and take years and years to master. But those aren't ones you're really expected to know in your exam. The ones I'm going to go through are the ones that are most commonly used in the UK and in Europe, and the ones that could come up in the exam. But like I said, there are others that exist. So you've got a butt joint. So simplest one, I mean, calling it a joint is a bit of a stretch, to be honest. Essentially all you do is you take your two pieces of material and just stick them together. There is not any real strength to it. It has to be very, very light. If you knock it, there's a very good chance it's going to break. Your mitre joint is very, very similar, but you've sand or cut a mitre into it. So mitre typically is 45 degrees. You can do other sized mitres as well, depending on the sort of shape you're after. It's still pretty weak. It still requires glue, but it just looks a little bit nicer. Our butt joint is quite an ugly looking thing, whereas a mitre joint looks a little bit neater, and you might reinforce that with something as well. Then you've got your dowel joints. So dowel joint essentially is you've got holes drilled into both pieces of material, and you have wooden pegs that will fit into both pieces of material, and you can put glue in the pegs, put glue in the hole, put glue on the surface, and clamp it together. Some pegs do have little grooves on the inside of it, so the glue will go inside the pegs as well. It's used a lot in flat pack furniture like chairs to put like bases and things on chairs. It's relatively strong as long as you make sure that all the holes line up. So normally if you're doing it by hand, you'll have something called like dowel pins. So you'll drill a hole in one piece of material, put the dowel pin in, put it back on top of the material, hit it with a hammer, and then the dowel pin will show where you need to drill the second hole. So there are methods to try and make sure it's done accurately. Typically, like in mass-produced stuff, it's all done by machine anyway. It's probably one you may have come across in secondary school already. Next, you got what I would normally call a finger joint, but it's also being called a comb joint quite a bit now as well. So used quite a lot in boxes. It can normally be machined out by like a CNC router, or it can be done by hand. It's not a massively complex one to do. It is very, very strong. It's used for quite a lot of things, but essentially, if you see here, it just means it interlocks. If you imagine like you put your hands together with your fingers interlocking, that's why it's called a finger joint, or that's why I call it a finger joint anyway. The only issue you may have sometimes is if you leave too much of a gap in between the pieces and they don't glue together, and you would reinforce it with glue typically. They're kind of similar, dovetail joint, except the benefit of a dovetail joint is that they have directional strength. So once you've actually hit them and placed together, you can't pull it apart in any other direction. Um, Doing these by hand are incredibly difficult. You can do it if you're a skilled woodworker by all means, but typically what you can do now is you can buy a dovetail jig. So with a router, you can actually do that quite simply. And the reason why it's called a dovetail is if you see here, basically this shape here is meant to just be the representation of a dovetail. Next, you've got mortars and tenon joints. So these will do like heavy duty framing for things. They're incredibly strong, reinforced with the glue. So what you've got is the hole is called the mortise. So we've got a mortise in college. So essentially that will let you drill square holes. If you don't have one of those, essentially what you do is you do drill loads of holes and then get a chisel and mallet and chisel it out. So the mortise is the actual hole itself. The tenon is the bit that sort of slots into it. So that typically will be cut out with either a tenon saw or a bandsaw. Gives you quite a big surface area. So glue on both sides, clamp it together, very, very strong. And there's no set size for your mortise and tenon joint. It depends on the piece that you're trying to do. But like I say, a very, very strong joint. Next, you've got your housing joint. So this is used in a similar sort of way in construction as the mortise and tenon joint. And it will let you do like shelving and that sort of thing. So what you'll have is a groove cut out of the surface of the material. So it's not at the very top or it's not at the very bottom. The two main ways for doing that really is the old school way would be you do a tenon saw, use a tenon saw to put two cuts into it, and then you chisel out with a mallet the rest of it. Or nowadays, typically what you'd probably do is use a router, set up a jig, set up a guide, and just route out that piece, and then it'll slot together nice and easily. And then a half lap joint is kind of similar to your housing joint, but rather than having it on an edge, you have it nice and fat, and the whole piece of material will slot into it that way. Typically, you'd either do that. You'd probably still do that with like a tenon saw and a chisel and that type of thing.